All right, in this video here, I have a couple example proofs that you're going to use as some guides to help you do the proofs for your homework. So there's an important concept that I want to kind of talk about, and I want you to show you how it's going to be used a couple different times. If you go back to the definition of congruent triangles that we talked about earlier last week, there's this abbreviation here that's actually kind of important. So this is on page 192. At the very bottom, we have the definition of congruent triangles. This definition should already be on in your notes, but if it's not, you should add it. Two triangles are congruent if and only if their corresponding parts are congruent, right? Okay, what I want to make sure that you understand here is this abbreviation, CPCTC, okay? And that's kind of right under here. It stands for corresponding parts of congruent triangles are congruent, okay? So CPCTC is kind of an abbreviation for the definition, but basically what it says is once you can show that two triangles are congruent to each other, you get all the other parts as well, okay? So the two example proofs I'm going to show you are both going to use CPCTC in different ways. Now, you won't have to necessarily use this for every proof on your homework, but at least half of them you're going to use this fact on there, okay? So let's go back here. Now, these aren't written down on your worksheet yet. So you're going to copy this image down and copy the given, and we'll do the proof together, okay? So what we have here is kind of this parallelogram looking shape, and I've labeled the corners A, B, C, and D. Again, kind of boring. And we have a line through it. And what we're going to start out with is that BC, the top guy, is parallel to DA. So this arrow marking on the figure indicates that they're parallel. And also, we're going to have them congruent. So the tick mark indicates that they're congruent as well. And what we're going to try to show is that these guys are congruent to each other. Okay, AB congruent to CD. That's where we're going. Okay. Now this is actually very similar to an example I did in class last week, but we're actually going to write a proof, and we're going to take it one step further as well. Okay, if we're going to try to show that this side is congruent to this side, the strategy is to start with the congruent triangles, right? If I can show that this triangle is congruent to this triangle, then all the corresponding parts are congruent. Right? So once I have these triangles are congruent, then this side's congruent to this side, and this angle is congruent to this angle, and this angle is congruent to this angle. In other words, I have all 6 pieces of information. Okay? So we're going to start out by, or the step right before here is to show that the triangles are congruent. Okay? When you're doing triangle congruence proofs, you got to look carefully to see what other information is there as well. And in this case, we have parallel lines, which probably means that we're going to use some parallel line angle theorem, like alternate interior angles. And that's exactly what we're going to use here. Okay, so let's start out here. We'll do a 2-column. If you want to do a flow or paragraph, if you prefer, that's fine too. Okay, so we're going to start out with the given, right? We got we got BC parallel to DA, and we got BC congruent to DA as well. Okay, given. All right. We also know some things about these other sides here, so let's take a look at this guy, right? This side is used in both triangles. Okay, so with the reflexive property, we can say AC is congruent to CA. Reflexive property, and we have another side. We already got one side. Notice we got BC congruent to DA, so we already got one side. Okay, so BC, we already have that piece. What we need is AC. AC congruent to CA, right? And that's reflexive property of congruence. Okay? Next, we notice that these are parallel lines cut by a transversal. Okay, so if we kind of like take out the sides for a second, we got parallel lines cut by a transversal. We get the alternate interior angles. So this line is kind of like this guy, and here are the two parallel sides, right? What we basically did is we took out this side and this side. So imagine that we had those two sides in there, we'd have our shape. We're just kind of extending. So what we know is if we have two parallel lines cut by a transversal, then the alternate interior angles are congruent to each other. So that means that this angle is congruent to this angle right here. Okay? And we already know that this guy is congruent to itself. All right, so if we're trying to prove these two triangles are congruent, which, you know, that's not exactly the whole thing, but that's kind of the strategy we're using. If we want to say that these two triangles are congruent, the options that we have is SSS, side, side, side. We could try SAS. We could try our new one, ASA, or another new one, AAS. Okay, in this case, we just got SAS right here. Okay, let's talk about that angle real quick. We'll put that in the proof, and then we'll go from there. So what we know is that angle BCA, this guy, BCA, is congruent to DAC, the ones that I marked there. So BCA congruent to DAC, and that's the alt int angles theorem. Okay. Therefore, we have triangle congruence here. We're going to say that triangle, let's say ABC, is congruent to triangle CDA. Okay. And that is going to be SAS, right? Now, if you're using SAS, what I would do, if it was me, I would go back and I would label and make sure I have all the pieces, right? So here's the angle that I was talking about. Okay, here's the first side, right? And here's the second side. So I want to make sure, I know this says SSA, but the order that I write them doesn't matter. I know that what I had was the side, the angle, and the side. So I'm just kind of listing to make sure, to double check that I actually did have all the information. So here's where the first side came from. Here's where the second side came from. And then here's where the angle in between them, the included angle, came from. So I'm just double checking that I have all the information. So I usually go back and put an S or an A next to the sides and the angles that I've stated that I have the information about. So we're good. Okay, now how does that help us? Well, now that I've proven the triangles are actually congruent to each other, I get everything else as a bonus, right? So what I know now is if two triangles are congruent, their corresponding parts are congruent, right? Or in other words, CPCTC. The corresponding parts of congruent triangles are congruent. So as soon as I show these are congruent, I got angle D congruent to angle B, right? I have AB congruent to CD, which is what I wanted. I actually have this other angle now, so I could go, whoops, make sure I have the same amount of markings here. 1, 2, 1, 2, right? And so I actually have 6 pieces of information congruent to 6 pieces of information over here. So my last step is to say, okay, cool, well, if the triangles themselves are congruent, then AB has to be congruent to CD because, make sure that's good, the corresponding parts of congruent triangles are themselves congruent. So again, once I show two triangles are congruent, I get everything else that I didn't have before. So I start with the minimum amount of information, SAS, right? Got a side, an angle, and a side. Therefore, the triangles are congruent. Therefore, I get everything else along for the right as well. Okay, so that is one way that you're going to use CPCTC. Some of the proofs that you're going to do in your homework will not, what you're trying to prove is actually not that two triangles are congruent. It's that two angles are congruent, or it's that two sides are congruent. But usually the step right before the last step is to show two triangles are congruent. Because as soon as you have those two triangles congruent, everything comes along for the ride. Okay. Let's take a look at example proof number 2, where we'll talk about another way to use CPCTC. All right. So in this one, we have a similar shape, right? We got this parallelogram, right? And we're going to start out with we're actually going to start out with a congruent statement. So in this case, it says triangle XMY, which is this guy, is congruent to triangle ZMW, which is this guy. So that's the given. They're telling us that, right? And what we want to prove is that this guy, XMW, is congruent to this guy, ZMY, right? So what we're going to do is we're going to use that fact again, that CPCTC. Okay. and that will help us get other pieces. So we're going to start out with the given triangle XMY congruent to triangle ZMW. All right, that's given. Okay, now what that's going to do is it's going to give me everything about those triangles, right? CPCTC, which means that this guy right here is congruent to this guy, and this guy is congruent to this guy, right? And this angle is congruent to this angle, and this angle is congruent to this angle, and this angle is congruent to this angle, and so on. Like, so we just kind of, sorry, let me make sure I got the right ones. So these two and these two, right? And then these guys and these guys, and then this and this. So we get basically everything about these two triangles. All 6 pieces is what we get, right? From these two. Now, if you think about what that means is like, okay, we want to show these two triangles are congruent. Well, we got this one, right? These two sides already, and these are vertical angles. So we're actually basically almost there. So let's start out by saying that WM, this guy, is congruent to YM. Okay. We'll also say that XM, this guy, is congruent to ZM. Okay, now how do we know that? CPCTC, right? The original given told me that the two shaded triangles were congruent to each other, which means we got 3 sides and 3 angles all congruent. Okay. Now it just so happens that 2 of those sides are sides for the other white triangles that we're looking at. Okay. So now we got 2 sides, right? Side, side, for these two triangles. Now we just need an angle in between them, right? Now these angles right here have to be congruent because they're vertical angles. So also angle XMW, this guy, XMW, is congruent to ZMY. Okay, how do we know that? Vertical angles theorem. Okay, and now notice that I have side, angle, side for these two, the white triangles. All right, we start with a congruent statement for the dark ones, get all the information there, and then we try to use that to get the 2 white ones congruent to each other. So now I can say that triangle XMW is congruent to triangle ZMY. By SAS again, right? Side, angle, vertical angles, side. Okay? So that's another way you can use CPCTC. If you get a triangle congruent statement somewhere in your proof, all of a sudden you get all the pieces working. Okay, so there's a proof like that in your homework. Okay, the rest of these proofs that you're going to do for homework. If you have any extra time in class, you can start them now and you can work together on them. But they're going to come from your textbook, and just make sure that you pay attention to what you're being asked to prove, and use some strategies that we talked about here. Okay. Other hints that you're going to use when you're looking through the figure, you got to make some inferences. So always look for parallel lines, right? Because that you can use like alternate interior angles. You can look for the word bisects or the word midpoint in your proof. Okay. Bisects or midpoint are going to give you like congruent segments or congruent angles. So those are keywords that you want to look out for. They're going to give you congruence. Other things to look for is like the reflexive property. Look for triangles that are sharing the same side or something like that, okay, or sharing the same angle. All right, so reflexive property you're going to use a little bit as well. So check those things out. Look for those pieces of information. Make the inferences that you need to. So that you have the information. Sometimes it won't all be like right there for you. You'll have to kind of make an inference using those things. So keep that in mind. Okay. I'm going to do one more video here that I'll probably put with your homework assignment to maybe just kind of give you some hints on the rest of the proofs that you're going to have to do. Thanks.